last video we talked about calculating angle between two vectors, and also we talked about the dots, that is the scalar product, and also the cross product, that's the vector product. And now today we will be looking at questions, and writing the questions. I'm talking about triple product vector. Okay, and thus we can talk about scalar triple product and also vector triple product. So I have some questions here that we are going to solve together, and so that we can have understanding fully established, because that is the main course of what we have here. So we'll start right into the first question. Okay, we'll start right into the first question. It says, given that we have a to be equals to 2I minus 3j plus k, and b to be I minus 3j plus k, and c to be minus I plus j minus 3k, we should evaluate a dot b multiplied by c, and a dot b cos c, which is also called this operation here is called scalar triple product, and we have a cos into b cos c, and this is also called vector triple product. And we can also be given to evaluate that a is equals to 5i plus 2j minus k, a b is equals to I minus 3j plus k. We should find a plus b, cross product a minus b. Okay, so let's start with the first one. Okay, number one. Now we are asked to evaluate a dot b plus c. Now from our knowledge of BODMAS, the first thing we will have to do is to solve what is in the bracket first. Okay, so we have to evaluate a dot b. Now let's rewrite the options that we have, the questions here. So I minus 3j plus k, b is equals to I minus 3j plus k, c is minus I plus j minus 3k. Now the first thing we have to do is to evaluate a dot b. Okay, then we multiply it by c. Now you will notice that the multiplication by c is not specified to be that dot product or cross product. Okay, so we just have to multiply directly by c. So let's evaluate a dot b. A dot b. Now a dot b will be multiplying the coefficient of let's say a. Okay, multiply the coefficient of 2 by 1. Okay, multiply the coefficient of minus 3 by minus 3, and multiply the coefficient of 1 by 1. Okay, so this is very important. Let's confirm our question again. I to be minus j. Sorry, there's a mix-up. This is 2i minus 3j plus k. This will be 4i plus j plus 3k. Okay. Yeah. This question is taken from engineering maths case short. We look at the further problems of chapter 6. We will see question 14 and 15. It's question 14 and 15. So you can quickly take a look at it. So now let's solve. Let's correct it here. Okay, let's correct it here. We have this to be plus j minus 3k. Okay, so when we want to evaluate our a dot b, we realize that we'll have 2 multiplied by 4. Okay, 2 multiplied by 4 plus minus 3 multiplied by 1. This is 1 here. Right? Plus 1 multiplied by minus 3. Okay, very, very important. And this will give us 8 plus minus 3 minus 3 plus minus 3 also. So this will give us 8 minus 3 minus 3, and 8 minus 3 minus 3 is 2. Now I want to go ahead and multiply our result of A dot B multiplied by C. Now this implies that A dot B, write it as 2, and multiplied by C. So in response, in conclusion, all they are asking us to evaluate is 2C. So 2C, that's 2 into C, which is minus I plus J minus 3K, and give us minus 2I plus 2J minus 6K. Okay, that will give us the solution to the first question. Now the second question we say is A dot B plus C. This is what they call scalar triple product. And in scalar triple product, like we did before, we solve what is in the bracket first before we have a dot product with C. Okay, so let's write out our vectors again. A is equal to 2I minus 3J plus K, and B is equals to 4I minus plus J minus 3K, and C is equals to minus I plus J minus 3K. So the first thing to do is to evaluate B equals C. Okay, and B equals C is similar to 3 by 3 matrix. So we add the components of B first. That's 4 plus 1 and minus 3. 4, 1. Okay, let's write it as 1 and minus 3. And the component of C, minus 1, 1, and minus 3. Minus 1, 1, and minus 3. So now we have to solve this. Okay, so this will give us I, and then we want to reduce it down to 2 by 2 matrices individually, like we have used, like we did in matrix videos. So this is I, and we'll be talking about 1 minus 3, 1 minus 3, 1 minus 3, 1 minus 3, minus J. Remember, we're using plus minus plus, minus J into 4 minus 1 minus 3 minus 3, and plus K into 4 1 minus 1 1. Now with that done, we multiply out taking the leading diagonal first for each case. So that is I. And so this will be 1 multiplied by minus 3, that's minus 3, 1 multiplied by minus 3, and minus minus 3, minus J into 4 multiplied by minus 3, that's minus 12, minus 1, minus 1 multiplied by minus 3, and that will give us 3, plus K into 4 multiplied by 1 is 4, minus 1 multiplied by 1, and minus 1. So that will give us I into 3 minus 3 minus 3 minus 3 minus minus 3 to give us 0, minus J into minus 12 minus 3, and that will give us minus 15, plus K into 4 minus minus 1, and that will give us 5. So this turns to 0, and we have 15J plus 5K. Now, having solved B equals C, then the next thing to do is to evaluate A dot B plus C. Now our A is what? 2I minus 3J plus K. We have here 2I minus 3J plus K, and we are going to have its dot product with 15J plus 5K. Okay, now since there is no I component here, we can rewrite the I component as 0i. Okay, so we can now perform the dot product here and say this will be 2 multiplied by 0. Now we are taking the individual components, multiplying them together and summing them, plus minus 3 multiplied by 15 plus 1 multiplied by 5. So this gives us 0 plus 3 multiplied by 15 is 45. That's plus minus 45 and plus 5. So our answer will be minus 45 plus 5, which will give us minus 40. Now, having been able to solve the scalar triple product with this format, we can also solve the scalar triple product directly without having to open the brackets. So let's go back and rewrite or a dot b plus c. Let's rewrite our question. Our a is equals to 2i minus 3j plus k, and our b is 4i minus plus j minus 3k, and our c is minus I plus j minus 3k. Now, to solve this directly into scalar triple product, we will work with our 3 by 3 matrices. And in our 3 by 3 matrices, the first row now will not be the components. Okay, it will not be the components I, j, and k. So the first components will be a1, a2, a3, b1, b2, b3, and the last component will be c3, c1, c2, and c3. Now this is what they call scalar triple product. Okay, scalar triple product. Now in this case, we have that our a1 is equals to 2, our a2 is equals to minus 3, and our a3 is equals to 1. Okay, now our b1 is equals to 4, our b2 is equals to 1, and our b3 is equals to minus 3. Our c1 is equals to minus 1, our c2 is equals to 1, and our c3 is equals to minus 3. Now after this is done, we will now slot it in a1 2, a2 minus 3, a3 1, b1 4, b2 1, b3 minus 3, c1 minus 1, c2 1, and c3 minus 3. Now with this done, we can now solve this directly as a 3 by 3 matrix determinant. Okay, remember it's still plus minus plus. So we have plus 2 into 1 1 minus 3 minus into minus 3 multiplied by 4 minus 1 minus 3 minus 3 plus 1 into 4 1 minus 1 1, and that will give me 2 leading diagonal minus 3 subtracting from the following diagonal minus minus 3, and minus multiplied by minus 3 and give us plus 3. 4 multiplied by minus 3 will give us minus 12, minus 1 multiplied by minus 3 will give us 3, plus 1. 4 multiplied by 1 will give us 4, minus 1 multiplied by minus 1 will give me minus 1. Now this will give it 2. That will give us minus 3. 2 into minus 3 minus minus 3. That's minus 3 minus minus 3. That will give us 0. Plus 3 into minus 12 minus 3. That will give us minus 15. Plus 4 plus 1 into 4 minus minus 1. That's 5. So this will give us 0 minus 45 plus 5, which will give us minus 40. And we can see that the answer here is the same thing as the answer here. Now, so this means that we can solve directly as having into using scalar triple product. That's where we have our 3 by 3 matrix determinant, or we solve according to the rules of Bodmas. Okay, where we take in the bracket first. So finally, there is another question related to that. We have the vector triple product. A cross into B cross C. Now, recall that our A is equals to 2I minus 3J plus K. And our B is equals to 4I plus J minus 3K. And our C is minus I plus J minus 3K. Now, in vector triple product, okay, the only way to solve a vector triple product is to solve bit by bit. So we take B cross C first, then results we have its cross product with A. Okay, so let's look at B. Let's look at cross B cross C. Okay, with that, now let's do B cross C. Now, as we have done before, now the first row is IJK. The second row will be the components of B. That's 4, 1, and minus 3. 4, 1, and minus 3. And the third component will be of C. Minus 1, 1, and minus 3. Minus 1, 1, and minus 3. So after this done, we can now evaluate. So we have I, reducing it to 2 by 2 matrix individually. Minus 3, minus J, and by it is plus, minus plus. Minus J into 4 minus 3, minus 1 minus 3, plus K into 4, 1, minus 1, 1. So I think we have even evaluated B cross C before. Okay, and our answer for B cross C is 15J plus 5K. It makes work easier. So our answer for B cross C, after doing all this, will be 15J plus 5K. Right? 15J plus 5K. So now, after evaluating our B cross C, now all we just have to do is evaluate our B cross C. Now, to make more sense, let's do this. So our A will be 2I minus 3J plus K, cross product with our B cross C, that's 15J plus 5K. Now, to solve this further, we will also apply the cross product method. Okay, so applying the cross product, so we will have that answer I, J, K. The first component will be of A, okay, that will give us 2 minus 3, 1, and the second component will be of B cross C, and that's 0I plus 15J plus 5K. Now, to solve this again, like we usually do, plus, minus, plus. Okay, so that means I, we're using to 2 by 2 matrix, 15, 1, 5, minus J into 2, 1, 0, 5, plus K into 2 minus 3, 0, and 15. So you consider the leading diagonal first. That's minus 15. The following diagonal also minus 15 minus j. 2 multiplied by 5 is 10. 0 multiplied by 1 give us 0 plus k. 2 multiplied by 15, that's 30. Minus 0 multiplied by minus 3, that's 0. So that will give us I minus 15 minus 15 is a minus 30 minus j. 10 minus 0 is 10 plus k. 30 minus 0 is 30. Now this gives us minus 30i minus 10j plus 30k. Now this will give our solution to A plus B plus C. Okay, A plus B plus C. So we've been able to talk on scalar triple vector and also be able to talk on vector triple product. Now, in our second question, we want to do a bit of a combination between the addition and subtraction, okay, and we have to find the cross product between them. So we will solve this together. So we were given in the question that A is equals to 5i plus 2j plus minus k, and B to be equal to I minus 3j plus k. And we are asked to evaluate A plus B cross product with A minus B. Now when we have A plus B, we are going to sum the individual component, that we're saying 5i plus 2j minus k plus I minus 3j plus k. And this will give us 5i plus 2j, and we open the brackets, plus I minus 3j plus k. Now let's do the I together. That's 5i plus I plus 2j minus 3j and minus k plus k. Now this will give us what? 6i. 2j minus 3j give us 2j minus 3j will give us minus j, and minus k plus k will give us 0. Okay, so we can just add it as a plus 0k. Now after evaluating A plus B, we now have to evaluate A minus B. That will give us 5i plus 2j minus k minus I minus 3j plus k. Now we open the bracket with minus 2i plus k. This will give us minus I, minus times minus give us plus 3j minus k. Now evaluating that, we have to bring our I together. So we have 5i minus I plus 2j plus 3j minus k and also minus k. So this will give us what? 5i minus I will give us 4i. 2j plus 3j will give us 5j. And minus k will give us minus 2k. Now going back to the question, we are asked to evaluate the cross product between A plus B and A minus B. So with respect to that, since our A plus B is this and our A minus B is this, so all they are asking us to do is to evaluate 6i minus j plus 0k first product with 4i plus 5j minus 2k. So after that is done, then we will have to use 3 by 3 matrix determinant, where the first row is the vectors ijk, the second row is the vectors, the coefficient of the vectors of 6, minus 1 and 0, and the last row is 4, 5 and minus 2. So after that is done, we evaluate simply, remembering we have plus, minus, and also plus. So we have I into minus 150 minus 2 minus j into 604 minus 2 and plus k into 6 minus 145. Now I into 2 minus 0, okay, minus j into minus 12 minus 0 plus k into 30 minus 4. So this will give us I into 2 minus j into minus 12 plus k into 30 minus 4. 30 minus 4 will give us 34. So this will give us 2i plus 12j plus 34k. Okay, so this will be the end of our vector videos, because we've been able to touch on the operations of vectors, the modulus of vector, the unit vectors, the directional cosines. That was in the first video, and in the second video we talked about dot products and cross products. In our next video, that's the third video, we talked about the angles between two vectors, and in this is our last video, we talked about our units, scalar triple vector and also vector triple product, or scalar triple product and vector triple product. I also picked one or two examples to solve. So, sure.